Alright, so in this video I'm going to pick up from where both of my classes left off. That way, if somebody from either class is watching the video, they can feel like where I'm picking up from where we left off in our previous class. So I'm going to begin with problem number 7. So problem number 7, the question they're asking is, what is the angle measurement here in degrees? Because this is the pi over 12 is the radian, so they're asking for the angle measurement. So pi over 12 would be one answer, but also there's an angle measurement in degrees. So a couple ways of doing that. Some students notice that in the unit circle that the pi over 12, they believe, divided the pi over 6 in half. So since pi over 6 is 30, they believe that pi over 12 is 15 degrees. I took a more numerical approach to it using an actual equation. So we were working with converting radians into degrees by taking the radian answer and multiplying it by 180 pi. And then pi divided by pi is 1. So what I end up with is 180 divided by 12. And that does equal 15 degrees. So, more than one way of getting there. So I want to just talk about the fact that that's how students viewed this as being half of the 30 degrees, but also a way of supporting that is using the equation that we've been working with for the last week or so. Listing 3 pairs of radian measures. I'm just going to go through this since this was a homework assignment. I may stop the video because there's some questions that are being asked. So they're asking for a radian apart. So I'm going to take the most obvious one. So if I start over here at 0, and then pi would be pi radians apart. So if I start at 0 pi and go to pi, those two are pi apart. Just as well if I start at pi and go to 2 pi, going from here to here, that's also pi apart. So that would be 2 examples. So if you haven't come up with an example, think about those 2 illustrations and can you come up with some of your own examples. And so turn the video off, work on that either individually or with your partner, and then turn the video back on when you are finished. So a couple other examples. If I start at pi over 2 and I want to go, again, pi distance to half the circle, I want to go to half the circle, pi over 2 would end up at 3 pi over 2. That would be a distance of pi. If I would start here at 5 pi over 12 and I want to go a half a circle, I would actually end up here at the bottom of 17 pi over 12. So that would be another pair of radians that are pi apart. And again, there are quite a few combinations here, so this is just 4 of them. So if you have yours plus these additional 4, what do you notice about the pairs? In other words, if I wanted to just give you one of the numbers, you didn't have a unit circle, and I wanted to find the other number, the other radian numbers, or can you come up with a way of doing that quickly? Or in terms of the circle itself, do you see any patterns that would let you identify quickly using this unit circle what 2 radians would go together? Turn the video back on when you are ready to continue, and we'll talk about problem 8 as well as problem 9. Alright, so I'm just going to look at a couple of these. So 0 pi and pi, that would be these 2 here. That would be the pi apart. Pi over 2 and 3 pi over 2, that would be these 2 here for the pi apart. The 5 pi over 12 and the 17 pi over 12, that would be these 2 apart. So I'm trying to emphasize here is that 2 radians that are pi apart are on the same diameter. So if I wanted to select this angle here, then the length that's pi apart would be on the other side of the diameter. And that would guarantee that, that would guarantee that those are pi apart. So another possibility would be 7 pi over 4 and 3 pi over 4. In problem number 9, you were supposed to come up with your own x and y answers. According answers, I asked you to turn your numbers into decimal numbers. And then each of you had a different quadrant. I divide the class up into groups of either 3s or 4s. So I'd like you to have a conversation about what appears to be the same about your answers, what appears to be different about your answers. When you're finished, turn the video back on. This actually, I believe, is where actually problem 11 is where we're supposed to end. So I'll talk about problem number 11 as well once we're done with problem 10. And then from there, you have to continue to work as a group to finish up the rest of this activity. You may find that as you're working through the rest of the activity, some of the problems I will spend time focusing in on, have a conversation. Some of the problems I may simply say to you, these are things I believe you can do without any additional conversation from me. And so we'll talk about these in our next class. All right, so go ahead and turn the video off and have a conversation about problems 9 and 10. So I'm hoping that you notice that you had a lot of the same answers over and over again. That some of the differences may be that the values were the same 2 numbers, but depending on the quadrant, sometimes they're both positive, sometimes both negative, sometimes you have one of each. I want to go back to this discussion we had earlier about reference angles. So like the original unit circle we did, pi over 6 and 5 pi over 6 and 11 pi over 6 and 7 pi over 6. Those all had the same 2 numbers for x and y. The only difference was the sign, whether they were both positive, both negative, or one of each. And that would be true for pi over 12. That's my reference angle if I go up 1 off of the x-axis. If I go up here 1, 11 pi over 12. Or if I go down 1, 23 pi over 12. If I go down 1, 13 pi over 12. These 4 radians here should have the same answer of 0.97, 0.26. The only difference for those 4 is whether they're both positive, both negative, or one of each. So that is something that's definitely the same about that reference angle, and that's true for a reference angle of pi over 6, which is 30, or pi over 4, which is the 45. And if I do a reference angle in going to each quadrant, the x and y values will be the same. What will change will be the signs. If you didn't have a conversation about how you determined the last 2, that would be the pi over 12 and the 5 pi over 12. Those were not part of the previous original unit circle. Have a conversation about how you determine those answers. And then we'll come back to that. But make sure you have a conversation about how you came up with those answers and see that if you, as a group, had more than one technique or applied a different rule to come up with the same answer. And the last problem that's assigned was 11, says other than 1, 0, 0, 1, negative 1, and 0 and 0, negative 1, all of the coordinate pairs on the circle are approximations. The 0.6 and 0.8 lies on the unit circle. What is the approximate radian measure for this point? So let's talk about problem 9. These 2 values here that was not part of the original unit circle. So when we did this original unit circle, we actually used sine and cosine as a way of getting there. So I went ahead and drew a circle. We know that pi over 12 is 15 degrees. That's what we proved in problem number 7. And so if I set this problem up, this is to solve for y, it's a sine problem. So sine of 15 degrees is going to equal to y over 1, which is y. So the y value will be sine 15. And if I wanted to find the x value, this would be cosine, because you have adjacent hypotenuse. So the cosine of 15 degrees is equal to x over 1, which is x. So if my calculator is set to degrees, not radians, and I put in the sine of 15 degrees, I get 0.2588, and and we got 0.26, and that's the sine's the y value. If I do the cosine, I get 0.965, and we get 0.97 here. So again, it rounds to 0.97. So one way of getting there would be using sine and cosine. And if you would did want to convert it into degrees and just want to keep pi over 12, then again, it's still a sine problem. So the sine of pi over 12 is equal to y over 1, so that's y. And cosine of the angle pi over 12, which is in radians, is equal to x over 1, which is x. And so as long as I change my mode to radians, I should get the same answer. So cosine's still in here. So cosine of pi divided by 12, this is the x value. I get 0.965, and again, that's about the 0.97. And if I change cosine to sine, I get 0.258, which again is about the 2.26 answer. So one way of getting there, and this may not have been the way that you guys came up with in your discussion, but one way of getting to the x and y value is to use sine and cosine. And we talked about that before break, and I wanted to bring that back up as a viable option. So in problem 11, they're asking the question, what's the approximate radian measure? So if I would take the same idea, and I know that the x value is 0.8 and the y value is 0.6, so 0.8 is here, 0.6 is here, and this is on the unit circle. In other words, if I would use Pythagorean theorem, 0.8 squared plus 0.6 squared should equal 1 squared. It's on the unit circle. And what they're asking for is that angle. And they want it in radians. So as a group, if you didn't come up with the answer, number 11, go ahead and figure out what the measurement is as a radian. And then see if the answer you came up with, does it fit this table. Turn the video back on when you as a group are ready to continue the discussion, and we'll take a look at this problem here and compare your answer back to the table. Okay, this is going to be the last problem for this video, and actually the rest of the handout works really well with the next lesson. So I'll start the next video with the remaining problems in this handout. So I went ahead and set the problem up for 0.6 over 1. That's going to be for sine opposite over hypotenuse. So I'm just going to do this using the rules that we've already been working with. And so I'm going to do inverse sine to both sides. And so if I put in inverse sine of 0.6, what I get is about 36 degrees. So if I want to turn this into a radian, we take the angle measurement. And I'm going to use the other rule that we talked about last class. We multiply by pi over 180. So it becomes 36 pi over 180. And 36 actually goes into 180. And so I end up with this 1 up here and 5 here. So what I end up with is the final answer of pi over 5. So if I would look back here, we're working on, and the decimal number was 0.86, so 0.86 is between 0.87 and 0.71, and thus pi over 5, is it somewhere between pi over 6 and pi over 4? And I hope we can agree that that works. If you're not sure, 1 divided by 4 is 0.25, 1 divided by 5 is 0.2, and 1 divided by 6 is 0.16, so 20 is between 16 and 25. So our answer of pi over 5 is a pretty good approximation for the angle measurement for the 0.8, 0.6 point on the unit circle. Go ahead and move on to the next video, and we'll pick up with problem number